moving on to solving proportions today. We're going to solve proportions both numerically as well as with word problems. You're going to be able to set up proportions and solve your learning target today. You can create and solve proportions involving real life situations. That's the main learning target today. You can do it numerically as well. It is review. Word problems is more what we come across. So, solving proportions. The first thing you want to do is set their cross product equal to each other. The relationship with proportions, the foundation of it says that their cross products are equal to each other. So that's always the first thing you want to do is set their cross product equal to each other. Right now you might be like, okay, what's a cross product? And cross products is when, let's define it here, cross product, just a refresher, if you had A over B equals C over D, if you had a proportion, given a proportion, the cross product would equal A times D equals B times C. So the product of these two is equivalent, is equal to the product of the other diagonal, okay? And then the last thing you're going to do is solve. So the first thing you're going to do is set the cross product equal to each other, and then you're going to solve. Okay, first example, and it's very important that you set it up this way. I really need you to set it up this way because tomorrow's lesson is going to be much more difficult, and you need to be comfortable with setting up cross products. So, according to solve this proportion, I usually always do with the variable side first. I say 16 times t, which is 16t, is equal to 10 times 20. 10 times 20 is 200. That's the extent of the work I need to see. That shows that you're applying your cross product knowledge. And now we just solve. In solving, how would I get rid of this 16? I would divide. So I'm going to say t equals 200 divided by 16. T is 12.5. No, it doesn't matter. Okay, the next one, setting the cross product equal. Again, my personal strategy, I like to deal with the variable first because I like my variable on the left-hand side. Okay, so I'm going to say the product of 17 and b, which is 17b, is equal to the other cross product. Okay, 3.8 times 5.1 is 19.38. Now I can divide. To solve for b, I have to divide. You don't have to show this step. You can just go right to the final answer like we did with the first example. 19.38 divided by 17 is 1.14. Okay, setting the cross product up on the next one. 7 over 10 is equal to 6.3 over W. In order to solve for W, we apply our cross product knowledge. And I use my variable side first. So 7 times W is 7W is equal to 10 times 6.3. I know right away that would be 63. Because I know anytime you multiply by 10, it's really moving a decimal over one spot. Okay? Anytime you multiply by 10, you're moving a decimal one spot to the right. Now dividing through by 7, W is equal to 9. I'm going to really be tedious with this last example. I should have done it first, just so you know where these numbers are coming from if you're looking at your notes and you want that refresher. So again, what I'm doing is setting their cross product equal to each other. So I'm going 2.5 times R, that's where this is coming from, I'm multiplying them, is equal, and now I do the other diagonal. 8 times 15, that's the cross product. The numbers across take the product. Product means multiply. 2.5 times R is really 2.5 R. And 8 times 15 is 120. Now, to solve, I would divide through by 2.5. And R would equal 48. So, make sure this first example, if you're one that you think, ooh, I might forget what cross product is, write all the steps, because this will be very, very helpful for you. I'm going to make sure that you guys are all caught up with me before I move to the next page. The last part of your learning target today was to apply it with real life situations. Anything related to word problems is really relating it right to real life. So proportions with word problems is really my favorite part of proportions. This is pretty much the generic way to set it up. A proportion, the first thing I always do is set two fractions equal to each other. And when you set two fractions equal to each other, you just created a proportion. And I have object A is to object B as object A is to object B. You're going to be given a relationship, and then you're going to be given an unknown. You always create the first fraction is always the relationship that you're given. So, I'll show you the first worked out example. 2 baseballs cost $6. There it is. There's a relationship. 2 baseballs cost $6. How much will 7 baseballs cost? And a rule of thumb is always put money on top. Money's always, it's ruling the world, okay? Money is always on top. So the first thing I always do is create my proportion fractions, setting 2 fractions equal to each other. Okay? And I have dollars is to baseballs. Dollar is to baseball. That's the relationship I'm given. I'm given dollars and baseballs. Okay? 2 baseballs cost $6. So $6 is to 2 baseballs. $6 is to 2 baseballs. As, how much will 7 baseballs cost? So again, we have dollars is to baseballs. Where's the 7 going to go? The top or the bottom? Bottom. The 7 is going to go on the bottom because it's a baseball. Baseballs are on bottom. Yeah? And now I put an X, and I'm going to solve. I solve with the cross product. So I set it up with 2 times X is equal to 6 times 7, which is 42. X is equal to 21. 21 bucks for 7.
21.
Huh? 21? What? I don't get it, yeah? Yeah. Why are we laughing? Did I do my math right?
No, it's a vine. It's a vine.
Oh gosh, okay. Ruthie?
You could have done it way easier.
How? Oh, found the unit price? So if I bought 2 for 6, that means it was $3 for 1. And then 3 times 7. Yep. Rafiq had another awesome strategy, which works really well when the number divides evenly together. He found the unit price. Okay? The unit price, he said, okay, if I paid 6 for 3 of them, 2 of them, then I paid $3 for 1. And then he took the $3 times it by 7.
Yeah.
That is a very effective strategy as well.
Good job.
Good job.
Proud of you.
Okay, if 4 CDs cost $54, how much are 3 CDs gonna cost? Okay, pay attention. 4 CDs cost 54. How much for 3? So what the relationship I have going is dollars and CDs. That's what I have going. Dollars is to CDs. Create my proportion skeleton. Okay? And I know that I should have dollars is to CDs as dollars is to CD. That's what I should have set up. So 4 CDs cost $54. Where's the 54 going to go? Top or bottom? Okay, what goes on the bottom? 4. $54 is to 4 CDs as 3 CDs is how much? So where's the 3 going to go? Bottom. And my variable goes on the top. Set their cross product equal to each other. I always put my variable first. 4 times x is 4x equals 54 times 3, which I do not know, and I put my calculator somewhere.
40.5.
How much?
I got 40.5.
Oh gosh, hold on. 54 times 162. Okay. Dividing through by 4, and I get x is equal $40.05 or 50 cents for 3 CDs. Okay? So, the unit price route that we were shown, that other strategy, is effective when you know perfectly how much one is going to cost. If you have to do any sort of rounding, don't use the unit price strategy. Use this. This is a very effective. Not to mention, I need you to practice this because tomorrow's lesson has everything to do with proportion. Setting up that proportion, not unit rate. Okay? So, we're good. Take your whiteboards out. We're going to practice a couple of them.